All right, so I want to show a couple quick examples of how we use the area multiplication tool. So on this, you can see this is a little different than the plate that we have if you watch the other video about how to use this for comparisons and addition. So this is left open, and so it goes from 0 to a tenth up to 1/10 here, and you see it's doing the same thing here. So it might seem limited, except on the back side here, you can see there's a little notch, and these extension rods, which this one is, let me get focused here, it's 1.1 all the way up to 2, and then we have another one that goes up to 3, and we kind of stop there because we don't want to take up an entire floor of your classroom. So I'm just going to make this a very simple example, because with the concrete examples, you don't need anything overly complex before you start working with the grid paper. You just need kind of proof of concept on a lot of these. And so something I want to kind of point out with this is that when you're doing these, it goes up to 1/10 times 1/10, or whole numbers times tenths. So the smallest you want to get is 1/10 to 9/10 in terms of the decimal places. And the largest, I would say, I would leave it up to 3 times 3 down to 0.1 times 0.1. And so we'll do, starting off like a fourth grade standard, we'll do something like 2 times 0.3. All right. And so this right here is basically showing us not just repeated addition, which that's very tempting to do, but we always want to relate this to a rectangle. So if this is a rectangle, one side has a length of 2, and the other side is a length of 3/10. And this is what we can model with this setup. So we have right here, we have this goes all the way up to 2. So we're going to fill from here to the top. And then right here, we need to look at what our bottom area is. So it's 3/10. So we need to figure out what the area is. So I can fill this up, and you're going to see how this goes pretty easily. And usually kids will do just the tenths because they're going to want the simpler approach. But every now and then you get a kid that they're going to be like, oh, I'm going to use the hundreds rod. Well, if they do that, they need to make sure these are all flipped around. And again, I'm not advocating that kids do this, but some will do it, and kind of let them, as long as they can say that this right here is 1/10. That's actually building their conceptual reasoning of this and allowing them to be kind of a smart aleck, or another type of smart person. You can imply what you want. But anyhow, this is 1, 2, 3, 4, 5, 6/10, and you can see that this is the cross section there. So we can make sure that this is 6/10. And what I like to do, and by the way, you can have the 0 or not have the 0. I think either is fine. But what I like to do is I actually like to give, and I'll do without the 0 just for the sake of comparison. I like to give students tables where they can start looking at the pattern. So they'll model it. You'll do this one with them and say, oh, okay, so this is 6/10. Okay, well, what are we doing here now? And then they can figure out that this is 2, this is 4, this is 8/10, and so on and so forth. And so then you can have a challenge round. Okay, well, now let's do 1.2. What's that going to be? And so then they can model it here, just kind of confirm. They have to prove it, so to speak. But then they can, sometimes you have to pick it up and put it in there, but then they can put a whole number here and here, and then they can add their 2/10 here and 2/10 here. You can't see that, but I'm limited a little bit here, but you can see how they can now put in the whole numbers, and then that's getting into this idea of partial products, where you're doing 2 times 1 plus 2 times 0.2, and that's connecting back to some of what they've been learning with partial products of whole numbers. All right, so let's put that aside for a moment, and I'm going to do a slightly harder problem. This is going to be more fifth grade level. I'm going to zoom in for this. You think it'd be getting bigger, but no, we're getting smaller. And I'm just going to do a tenth times a tenth. And we're going to do the same sort of setup. We're going to do a tenth times a tenth times 2 tenths, a tenth times 3 tenths, and so on and so forth. And then we'll do a little challenge around a tenth times 8 tenths. All right, so for a tenth times a tenth, okay, here's a tenth and here's a tenth. Remember, we're doing our rectangle, so we need a rectangle. And you know what is nice about this being open? I can kind of like draw right in here what that's supposed to be. It can just be like a rough sketch. Well, a tenth times a tenth, that's my area. Well, what size is that? What's a tenth of a tenth? And the answer is 100th, of course. And so we can fit that in there because, you know, you can see that fit in there. And we can have this conversation of, okay, this is a tenth times a tenth, so this is a tenth of a tenth, right? Like we use that fraction multiplication language. So you can see that a tenth of an entire tenth is 100th because this is already cut up into 10 equal parts. So this is a conceptual tool, like, oh, this is a tenth of a tenth. And so you can have that conversation while it's also a rectangular, well, square in this case, but you get the idea. But you're modeling area here for multiplication, but you can also model that fraction reasoning aspect as well. So if you write 100th over here. All right, and then you can do the same thing with 2 tenths, and all the adults are going to know what the answers are. But as you're modeling this, it's doing a couple of things. It's getting the connections back to those fractions reasoning. So it's like, okay, this is a tenth of 2 tenths. So it's a tenth of each of those tenths, which is the same as a tenth of 2 tenths, and so on and so forth. So it's kind of connecting multiple connection points, repeated addition, fraction reasoning, looking at this being a tenth of these 2 tenths, and you can actually see the partitions here as an array. And so then the other aspect here is if you're writing it as a table, you get this connection with seeing the pattern of why we have 2 decimal places here, what's actually happening, because when you're doing a tenth times a tenth, you're getting into hundredths territory. And so that works great. And then you can move on to 2 tenths times 8 tenths and so on and so forth. You can kind of extend this pattern, and so a lot of different ways of connecting, making sure they're seeing this with written numbers, but this helps to build that meaning. You're not trying to replace written numbers or anything like that. We're not doing anything crazy. We're just trying to get them to understand what these written numbers mean. So that's an example of how you can use these. Hopefully it's helpful.